Hello there. Today we will work on some problems from 12.7. 12.7 is not in our textbook, but it's in my handout where I get this from our older textbook, older edition of our textbook. This section actually has conversions, okay? So we learn from rectangular coordinate system. We learn to convert to cylindrical, which if you think about it is basically polar plus z-axis. Okay, and after that we learn spherical coordinate system, which if you think about it, it will keep the theta. So here we have r theta z. In cylindrical, in rectangular we have x, y, z. Right, so basically this xy here now becomes our theta. Right, now in spherical we have rho theta phi, okay, in which it maintains the theta from polar. It maintains the theta from polar, okay, and then change the rho phi. Now I assume you already seen my lecture, the actual lecture on how to convert this, okay? And basically you should be able to convert from any one of the coordinate system to the other ones. Now, we don't need this section right away, right now, but instead of waiting until when we really need that 2 chapters later, I want you to start thinking this way, start feeling about it, start having some understanding in it. Okay. Now, but instead of like doing just conversion, which I think quite easy, but you need to do a lot of practice, we will go on with the harder part, but more important part, where we will need to be able to describe and visualize, if possible, a surface given an equation not in rectangular equations. Okay, I try to do as many as possible here, but at the same time I may not be able to do so. Okay, let's start. Number 31. Describe the surface whose equation is given by r equals to 3. Now, because it is r, we know that's a polar. I'm sorry. Yeah, it's polar in 2-dimensional. And it is cylindrical in 3D, right? In 2-dimension, it's basically a circle with radius 3 centered at origin, right? Okay, but what happened in 3D? In 3-dimension, it will be, of course, the cross-section on the XY plane will be a circle, but then we will copy this circle along the missing axis. In this case is the z-axis. Okay, so then if we copy it that way, then we will see, oh, it's actually a cylinder with axis. It's a circular cylinder with axis on the z-axis with radius 3. Okay, now of course it doesn't just go up above the xy plane, it also goes below xy plane. Now that's for number 31. How about number 32? Rho equals to 3. Now this is spherical notation, which means the distance from origin is 3. Now in rectangular coordinate, rectangular equation, that will be x squared plus y squared plus z squared equals to 9, right? Because rho squared equals to 9. This is in rectangular equation. Okay, and in polar equation, there will be r squared plus c squared equals to 9. This is in, I'm sorry, not polar. I keep on saying polar, cylindrical. Okay, this is a sphere with radius 3, center at the origin. Okay, this one here is circular cylinder with radius 3 with c axis as its axis. Okay. Number 33, how about phi equals to 0? Number 33, phi equals to 0. Now, this is the same to cosine phi equals to cosine 0, right? But cosine phi is, let's see, cosine phi, if you remember, that's the z over rho. Is it right? This is the z-axis here, right? Okay, this is the phi. Okay, let me make it nicer. And this is the r, right? Okay, but if we use cosine, that will be z over rho equals to 1, or c equals to rho, which means z squared equals to rho squared, which is x squared plus y squared plus c squared. Am I missing something here? Hold on. I think I missed something. Yeah, I know if c. Oh, yeah, that's right. Then I get x squared plus y squared equals to 0. But this only means x and y has to be 0, right? Okay, for every z. In other words, we have coordinate 0, 0, c. Oh, this is just the z-axis, huh? Yeah, imagine if the phi turns out to be a 0, then it will be here, right? Okay, but I think I need to say something more. That the c has to be non-negative, is it right? Which doesn't really appear here. I have to say that c is at least 0. Because if the c is negative, then the phi will be pi. Is it right? Okay. Number 34. I somehow think it's supposed to look like an xy plane, but then I realized, oh, the phi is equal to 0. How about when the phi equals to, oh, this is the one, when the phi equals to pi over 2, number 34, phi equals to pi over 2 means the angle is 90 degrees from the positive z-axis, right? But that will just be the xy plane. This is just the xy plane. Now the thing is, how do I show that algebraically or geometrically? I mean, this is geometrically. We know that it's xy plane. But can we do algebraically or trigonometrically? Okay, so cosine phi equals to cosine pi over 2, that c over rho equals to 0 means c equals to 0, right? Okay, now z equals to 0, we know that's xy plane. Okay, it's number 34. How about phi equals to pi over 3? We give more space to myself. Phi equals to pi over 3. Number 35. Phi equals to pi over 3, which means it forms 60 degrees from the z-axis, right? But then you will rotate that. So you will see that's actually a cone opening up with axis at z-axis, right? Now the thing is, can we show the equation for that? Again, I will use cosine. So this is z over rho equals to 1/2 2z equals to rho, so 4c squared equals to rho squared, which is x squared plus y squared plus c squared. So this is 3c squared equals to x squared plus y squared. Now from 12.6 or 12.5, I don't remember, we know that this is actually a cone. Okay, now not bicone though, not two cones like the one we usually have in quadric surfaces, right? No, only the one facing up. Remember, because the phi is pi over 3, the phi is not 2 pi over 3. Okay, so this is the cone with axis z-axis. Okay, in fact, we can say this is circular cone with axis positive z-axis. Okay, number 36. We have theta equals to pi over 3. Theta equals to pi over 3, but for theta we use tangent, It's tangent pi over 3, but tangent is y over x. That's radical 3, so y equals to radical 3x. Now in two dimension, this is x, this is y. It is actually a line with slope radical 3 through the origin, right? But in 3 dimension, it's missing a z, therefore it becomes quote-unquote a cylinder parallel to the z-axis, right? So if I try to draw it, it will look like this. Now the thing is, in polar and in cylindrical, the theta may have negative radius, so it is actually a plane parallel to z-axis going through z-axis. Okay, but the theta is pi over 3. This is pi over 3. Okay, that's the x-axis, this is the y-axis, and this is the z-axis. Okay, let's go on further. Those 6 questions are the basic equations. Okay, let's go on further, the harder one. Identify the surface whose equation is given. Number 37. Z equals to r squared. But z equals to r squared in 2 dimension, it looks like, if this is r and this is z, it looks like a parabola, right? Now we know this is a cylindrical coordinate system, but then because the theta is not mentioned, there's no restricted for theta, then we basically rotate that or revolve that around the z-axis. Okay, so you will see this is what we actually have. Okay, this is a paraboloid. People may say this is a circular paraboloid simply because the cross-section of this paraboloid is a circle. Okay, that's for number 37. Number 38, let me do it here. Number 38, try to save some space. R equals to 4 sine theta. Again, this is a polar coordinate, a polar equation in 2 dimensions. Okay, and I hope you realize we have done this before, supposed to be in Calc 2. Okay, this is x squared plus y squared equals to 4y. And it gives us, fast forward, I will add 4 to complete the square. So I get x squared plus y minus 2 squared equals to 2 squared. This is a cylinder in 3 dimensions. In 2 dimensions, it is a circle centered at 0, 2 with radius 2. Right? But in 3 dimensions, then it becomes cylinder. Notice because it's missing the z component, right? Z variables. So it is a cylinder centered at this line here. Okay, the line of x equals to 0, y equals to 2. Okay, and it is a cylinder with radius 2 as well. Okay, but the axis of that cylinder is this line, x equals to 0, y equals to 2. You need to get used to this though. Okay, in some sense, since you already passed Calc 2, and I did teach trigonometry in the past, this is something you're supposed to learn in trigonometry as well, for polar, right? Then you should actually know that graph, okay? Rho cosine phi equals to 2. Let's try to picture it. So if this is phi, and so this is C, this is rho. You see that cosine phi is equal to C over rho. Therefore, rho cosine phi will give us Z equals to 2, right? This is a plane. Okay, Z equals to 2, which means this plane is parallel to XY plane. Okay, number 39. That's number 30. Number 40. How about rho sine? Rho sine phi equals to 2. From this picture here, you will see this is basically the R equals to 2. But R equals to 2 means x squared plus y squared equals to 4, right? This is a cylinder, circular cylinder with radius 2, okay, with axis Z axis. That's number 40. Let's go on. Number 41. Notice that I don't really do this though. I don't really do even and odd problems in my when I do the supplemental videos like this, like when I do exercise. Now, one of the main reason is I believe you guys need to get more exposure on this conversion of rectangular, cylindrical, and spherical coordinate system, and move forward learning and be comfortable with dealing with the equations. Okay, in the next 2 chapters, it will be more painful when we need to do integration on those. Unfortunately, our newer edition textbook assume at that point you already get used to this, while at the same time they took this section away from the newer edition, which is very strange. Okay, now this is a polar equation, right? So this I multiply by r both sides. I get x squared plus y squared equals to 2x. Then you will see it. I add 1 to complete the square. I add 1 to complete the square here. So I get x minus 1 squared plus y squared equals to 1 squared. That is a circle centered at 1, 0 with radius 1 in 2 dimension. But in 3 dimension, then it becomes a circular cylinder centered at 1, 0, z. In other words, that should give us a cylinder with axis at x equals to 1 and y equals to 0. Okay. This is the axis here. That's for number 41. Now, what if we change to number 42, where we have rho equals to 2 cosine phi. Now, remember, cosine phi is c over rho, right? In other words, now we have rho squared equals to 2c. This must be a circle, huh? I mean, this must be a sphere with different center. X squared plus y squared plus c squared minus 2c plus 1 equals to 1. So x squared plus y squared plus c minus 1 squared equals to 1. This is a sphere center at 0, 0, 1. With radius 1. Okay, so it is kind of like it's a ball sitting on xy plane. Okay, let me draw the cross section. Okay, the center is here, and the center is 0, 0, 1. Okay, that's for number 42. Number 43 is r squared plus c squared equals to 25. Oh, by the way, but this is actually rho squared equals to 25, rho equals to 5, right? So this is a sphere centered at origin with radius 5. Okay, actually we can also play this way. This is actually x squared plus y squared plus c squared equals to 5 squared, right? So it will give us the same conclusion. Number 44, r squared minus 2c squared equals to 4. Number 44, oops. R squared minus 2c squared equals to 4. But r is x squared plus y squared minus 2c squared equals to 4. This one here will give us, I believe, hyperboloid, right? This is what it looks like. In 2 dimension. If this is r and this is c, okay, it will give us hyperboloid. But then if I spin it around c axis, it will give us hyperboloid of one shape. In fact, we have with axis, z axis. Okay, that's for number 44. Let's go on. Number 45. We have rho squared, sine squared, phi cosine squared theta plus cosine squared phi equals to 4. Rho squared, sine squared, phi cosine squared theta plus rho squared cosine squared phi equals to 4. I know this is c squared, right? And this is what? X squared? Okay, so this is cylinder, circular cylinder. Circular cylinder with radius 2 and axis y-axis, right? Okay, if you think about it, this is if this is x and this is z, here is a circle with radius 2 center at that origin, but extend this in the y direction. Okay, if you extend it in the y direction, let me enlarge this, too small. Yeah, if we enlarge this in the y direction, yeah, then you will see it actually looks like circular cylinder. Okay, that's for number 45. Number 46, rho squared times sine squared phi minus 4 cosine squared phi equals to 1. This is rho squared sine squared phi, that's r squared by the way, minus 4 rho squared cosine squared phi equals to 1. This is r squared minus 4 cosine c squared equals to 1. If this is r, this is c, it will look like this. And then we rotate that around. Oh, hyperboloid again in one sheet. Wait, we have something looks like that, right? Yeah, you see that this is basically r squared minus something z squared equals to 4. Okay. And then, yeah, it's similar. So this is hyperboloid in one sheet. With axis z axis. Okay. And then number 47, r squared equals to r. Oh, r squared minus r equals to 0. So r equals to 0 and r equals to 1. Oh, then that is one of them is a point at origin and the other one is a unit circle. Okay, now the thing is, if we see this in 2 dimension though, but if we see this in 3 dimension, then it will be in 3 dimension, then it will be the z-axis. That's what happened to the dot if you extend it in z direction, and the circular cylinder centered at z-axis with axis z-axis with radius 1. Okay, so we have z-axis, that's for r equals to 0. Okay, and then r equals to 1 give us circular cylinder with radius 1 with axis z-axis. And I think number 48 is very similar, but instead of a cylinder, that will be a two sphere, right? Okay, so number 48, yeah, we do factorization there. You will see that's rho minus 4, rho minus 2 equals to 0. This is rho equals to 4 and rho equals to 2. Those are spheres. Should we say concentric sphere? Concentric, because they have the same center. Concentric spheres centered at origin with radii 2 and 4. Okay, so it looks like this and this. Okay, but you rotate that around the z-axis or the x-axis, or the basically becomes two spheres. Okay, next. Write the equation first in cylindrical coordinates and then in spherical coordinates. Number 49. And part A, z equals to x squared plus y squared. For part A, that's z equals to r squared. I believe that's enough, right? Okay, and part B, if we need to write it in spherical, z is rho cosine phi, right? And then r is rho sine phi, because I square it. Then you see I can cancel one of the rho, right? And then divide by sine squared phi equals to rho. So you will see rho is cosecant phi, cotangent phi. Okay, so this actually gives us the equation of a paraboloid facing up, right? This is a paraboloid facing up. Okay, but the spherical equation looks quite ugly, so we don't really use that, but the equation in cylindrical is actually quite nice. Okay, number 50, x squared plus y squared plus c squared equals to 2. This is a sphere centered at origin with radius radical 2. In part A, that's r squared plus c squared equals to 2. In part B, this is rho squared equals to 2, or simply rho equals to square root of 2. Okay, that's easy. Number 51, I think that one is also easy. Number 51, x equals to 3. So in cylindrical coordinate system, this is r cosine theta, right? R cosine theta equals to 3. Which means, usually we solve for r, right? So r equals to 3 secant theta. Now, even though this is a simple equation, I honestly do not expect you to memorize this equation in polar or the equation in cylindrical, because the equation in rectangular is simpler, right? Okay. How about in spherical? Rho sine phi cosine theta equals to 3. So rho equals to 3 secant theta cosecant phi. Okay, number 52. X squared plus y squared plus z squared plus 2z equals to 0. We know this is actually a sphere. Let's play around with this. This is actually a sphere centered at 0, 0, negative 1 with radius 1. Okay, This is a sphere centered at 0, 0, -1 with radius 1. So you will see this sphere is actually below xy plane. Okay. However, if we try to make it into cylindrical equation, that will be r squared plus c plus 1 squared equals to 1. Right? Okay. Remember, for cylindrical, we keep the z, we just need to modify the x and y. Okay. However, for the cylindrical, I think I will play with x squared plus y squared plus z squared, that's rho squared, while the z is rho cosine phi equals to 0. Is it right? Now I will factor rho equals to 0 out. So I get rho plus 2 cosine phi equals to 0, or rho equals to 2 cosine phi. Oh, negative, I'm sorry, negative. Now you can try to mimic this with r equals to -2 cosine theta. That will give us something like this. Okay, the center is -1, 0, right? Okay, now the thing is, if we try to picture this, this is actually below xy plane. So if I have xy plane, the circle or the sphere is actually below xy plane. Okay, it's below xy plane. So if you can see the relationship between these two, you may have a way to picture them faster in future, but not necessary. Yeah. Number 53. I do not want to expect too much from you in the first time you see this section, okay? But you may want to review this again and again and again until you get used to it, okay? It's not about what the common shape look like, but how to transform them. I believe that's more important. So this one here, this is r squared cosine squared theta minus r squared sine squared theta minus 2c squared equals to 4. This is r squared times cosine squared theta minus sine squared theta minus 2c squared equals to 4. This is r squared cosine 2 theta. I hope you remember that. Yeah, so this will be the equation in two-dimensional. In cylindrical. In spherical, you will see I can go on from r and z, where the r becomes r rho squared sine squared phi cosine 2 theta minus 2 rho squared cosine squared phi equals to 4. Notice then I can cancel the rho squared, right? I can divide by rho squared. Actually, no, because the other side is not 0, huh? The other side is not 0. Yeah, if it is 0, then I can, but here, no. So rho squared, and then sine squared phi cosine 2 theta minus 2 cosine squared phi equals to 4. I think that's the furthest we can go. Okay. Yeah. What does this look like? This looks like x squared minus y squared plus 2z squared equals to 4. What does it look like? X 56x, and this is r, so it will look like this. It will look like this. So that's hyperbolic in two sheets. I don't think so. Hold on. I think I confused myself. It's supposed to look like this. No, I don't think so. That was right. Yeah, that was right. In 3 dimension, it looks like yeah, hyperbolic in two sheets, and you have one more back there. Okay, that's for number 53. 54, I think that one is easy. Y squared plus C squared. Y squared plus C squared equals to 1. So that's actually a circle on YC plane, but if you extend it in the X direction, that will be a circular cylinder with radius 1 with axis x-axis. Okay, now the thing is, what will that be in cylindrical coordinate system? The y is r squared sine squared theta plus c squared equals to 1. We just leave it like that. For the spherical, it will be rho squared sine squared v sine squared theta plus rho squared cosine squared phi equals to 1. Okay, the most we can do is to factor the rho squared out, and I think that's basically it, huh? Yeah, that's the furthest we can go. Number 55. X squared plus y squared equals to c squared. I'm sorry, equals to 2z. What am I doing? 2z. So in cylindrical, this is r squared equals to 2z. That's the furthest we can go. I'm sorry, it's not c, it's y. My bad. We can do more then. This is y, so this will be r sine theta. Is it right? Okay, and this is r equals to 2 sine theta. You notice that this is basically a circle centered at 0, 1, not like this, sorry, centered at 0, 1 with radius 1. Okay, but in cylindrical, then it is actually a cylinder like this, but you extend it in the z direction. Okay, so in 3 dimension it looks like this. And then the spherical, that will be rho sine phi equals to 2 sine theta. Okay, if we try to solve for rho, that will be 2 sine theta cosecant phi. That's for number 55. Let's see. I think 56. Can I just let it go? I'm lazy already. Number 56, that's z equals to x squared minus y squared. Well, this is the, what do you call that? Hyperboloid, paraboloid. The one that looks like this. The one that looks like this. And then where the one with this, we call this saddle point, where from, if we travel along this red path there, that will be the local maximum, right? But if we travel along this path here, it will be local minimum. Okay. But then what will that be in cylindrical coordinate system? That will be c equals to rho squared cosine squared theta minus rho squared sine squared theta. I factor the r squared, and cosine squared theta, sine squared theta, that's cosine 2 theta. Okay, and then finally, the equation is spherical. That's rho cosine phi equals to rho sine squared phi cosine 2 theta. If I cancel the rho, then I will get cotangent phi secant phi and secant 2 theta. Okay, if I solve for rho. Okay, well, that's what we have for number 56. Will that be all? Okay, now let's go on. I think this is the last part of this section that I want to go over. This time we deal with inequalities. Okay, so number 57, we have r squared is less than equals to c less than equals to 2 minus r squared. Now, let's see the surface first, which becomes the boundary. Remember, for inequality, we always find the boundary first by setting them equal to each other. So r squared equals to c is what? That's a paraboloid, right? That's a paraboloid. Okay, now you need the c greater than, it means above this paraboloid. And the second surface is also paraboloid, but it's upside down. The vertex is 0, 0, 2, right? Now the c has to be between these two guys. So if I put things together, one of them below, bounded below, okay, and then another one bounded above. Let me use what color? Green color. Okay, and this is the z-axis. That's for number 57. Number 58, we have theta between 0 to pi over 2. Okay, so it's basically in the first quadrant, right? If it is 2 dimension, it is first quadrant. And then the z is greater than r but less than equals to 2. So what is this though? This will give us a cone, right? R equals to c is a cone. This is r, this is c, that's a cone. But the c is at most 2, so it's bounded above by this plane c equals to 2. And at the same time, it has to be in the first quadrant in 2 dimension. So imagine this. Let me take this again, and then I enlarge this because I think it's a nice graph already, a nice sketch already, right? But then I only pick the part that is in the first quadrant. Maybe in this case, then it becomes in the first octant. Okay, so that's what it looks like. Okay, imagine that. Like, imagine if you have a cone, right? Imagine if you have a cone, you cut it above at height c equals to 2, and then you cut it along the YC plane and the XC plane. Okay, so you end up with this part only. Okay, that's for number 58. To visualize, that is the hard one though. Now, if you don't practice sketching the graph, then you will have harder time. I know my sketch is not good. My sketch is not good, but we will need this later on, especially when we do triple integrals. Okay, number 59. Rho is less than equals to 2. Now, this is actually a ball, not a sphere. A sphere basically just the skin, right? This is a ball, means the sphere and the internal ball with radius 2. Okay, but the phi is between 0 to pi over 2. Remember, phi equals to 0, that's the z-axis, right? And phi equals to pi over 2, that's xy plane. So you will see that's a ball with radius 2, but it is on the top part. Okay, that's a semi ball. I don't know if we have anything like that. So it's a half ball, okay, where the radius is 2, but the c is positive, or at least 0. Okay, but no, we are not done yet. And then we see the theta is between 0 to pi over 2. Oh, so that means it is in the first octant. It is first, together with positive c, right? Together with positive c. This is the first octant. So that semi-ball, we cut it further into half. It becomes just a quarter of a ball, huh? What will that look like then? I think that will look like, let me erase this. I don't like that. I don't like this statement here. It will look like this. So it looks like a sphere, but you cut it and get it only in the first octant. Okay, I hope this shades here helps us to see that as part of a ball. It's actually 1/8 of a ball instead of just a quarter of a ball. It's 1/8 of a ball. Okay, that's for number 59. Number 60. Rho is between 2 to 3. Oh, okay, then this is basically what? You call that hollow ball? Like, so you have a ball, but the inside is empty, right? The radius is between 2 to 3. So imagine this donut here, but use it becomes a ball. Okay, and then what else? The phi is between pi over 2 to pi. Remember, phi is the angle from the c-axis, right? Okay, this is positive c-axis. Then pi over 2 is the xy plane, and pi is the negative c-axis. So we are talking about this region, huh? Okay, now then imagine if you take this hollowed sphere and you cut the top away, it becomes like a semi-hollowed sphere. like this, maybe, right? Okay. Okay, so you have a sphere with like empty inside, and then you cut it in half. You only take the bottom part. That's number 60. Number 61. Let me do it here. Number 61. We have theta is from negative pi over 2 to pi over 2. So that's quadrant -1 and quadrant 1, right? You will see if this is basically when the y is at least 0. Okay, does it make sense? If this is x and this is y, no, it's actually x is at least 0. Okay, this part here, quadrant 1 and -1. And then what else? The phi is between 0 to pi over 6. The phi is between 0 to pi over 6. Okay, so it is actually the fill-up cone, but we only take the part where the x is positive. Let me make it bigger. We only take the part where the x is positive. Okay, and then the last part is rho is between 0 to secant phi. The rho is from 0 to secant phi. Okay, so that will be rho cosine phi is less than 1, but rho cosine phi is what? Z? Okay, so the maximum is C equals to 1. Okay, it's bounded above by C equals to 1. Okay, and that's the cone with x at least 0. And the angle formed from positive c-axis is pi over 6. Number 62, the phi is from 0 to pi over 3. Number 62, the phi is from 0 to pi over 3. Okay, so if this is c from 0 to pi over 3, that's actually a cone, right? But the cone is actually going infinitely far. But they also say the rho is less than equals to 2. Means it is part of the sphere. Oh, that reminds me to ice cream cone, huh? That reminds me to ice cream cone. So let me try to sketch that. This is the intersection between the sphere and the cone. It's bounded below by that cone. And bounded above by a sphere. Okay. Okay then, this is for this section 12.7. Let me change this part here. It should be 12.7. Okay.